In a revelation that could redefine humanity's place in the universe, NASA has confirmed the detection of what appears to be the first extraterrestrial signals originating from the direction of Proxima B, the closest known exoplanet to Earth, orbiting just over 4 light-years away within the habitable zone of its parent star, Proxima Centauri. This announcement has ignited a wave of excitement, speculation, and cautious wonder around the globe. Could this be the moment we learn, definitively, that we are not alone? The path to this moment began with years of painstaking observations by some of the most advanced telescopes on Earth and in space. Proxima B has long been one of the most compelling candidates in the search for extraterrestrial intelligence due to its Earth-like size, rocky composition, and location in the Goldilocks zone, where liquid water could exist. Now, astronomers have identified a signal unlike any they have encountered before, distinct, highly structured, and impossible to attribute to any known natural phenomenon. If confirmed, this could represent a turning point in human history. It would not only strengthen the long-held scientific theory that life could develop on planets beyond our own, but it might also point toward the existence of civilizations capable of deliberate interstellar communication. The very idea prompts an overwhelming number of questions. Is the sender a technologically advanced society or something simpler? Is the message a greeting, a warning, or something we cannot yet comprehend? What makes this discovery so compelling is the nature of the signal itself. It is not random static, nor the byproduct of stellar activity. Instead, it carries a precise, repeated pattern, the kind of order typically associated with intelligent design. NASA scientists, working alongside international research teams, are now attempting to decode its structure and determine its meaning. Around the world, the scientific community is abuzz with theories, each trying to imagine the intent and origin behind the signal. Outside of laboratories and observatories, the story has taken hold of the public imagination. Social media threads, televised debates, and dinner-table conversations all circle back to the same questions. If there are beings on Proxima B, what might they look like? How advanced could they be? What kind of world might they inhabit? Could their history, technology, and culture be completely alien, or might we find surprising similarities to our own? The detection of a potentially intelligent signal also raises deep ethical and philosophical concerns. How should we respond if it is, indeed, a message? Should we answer at all, and if so, who should speak for humanity? What protocols, if any, exist for interstellar diplomacy? And how might this change our understanding of religion, identity, and humanity's role in the cosmos? While excitement is building, caution remains paramount. Leading scientists are focused on eliminating every possible explanation that does not involve intelligent life. They are examining the possibility of signal interference, unknown natural sources, and technical anomalies before moving forward. Every stage of analysis must be handled with extreme care, as the stakes are unprecedented. The timeline of this search stretches back several years. In April 2019, astronomers detected a mysterious radio transmission originating from the region of Proxima Centauri, a star system 4.37 light-years away. Though far, it is our nearest stellar neighbor, part of a triple star system with Alpha Centauri A and Alpha Centauri B, alongside the red dwarf Proxima Centauri. Alpha Centauri A is a bright yellow star roughly 1.5 times more luminous than our Sun, while Alpha Centauri B glows with an orange hue at about half the Sun's brightness. Proxima Centauri, the faintest of the three, is a small red dwarf that hosts Proxima B in its habitable zone. The breakthrough came from the Breakthrough Listen initiative, a $100 million project dedicated to finding signs of extraterrestrial technology. This ambitious program has devoted thousands of hours to scanning the skies with some of the world's most sensitive instruments. The signal in question, now referred to as Breakthrough Listen Candidate 1, or BLC-1, was picked up by the Parkes Radio Telescope in New South Wales, Australia, during a targeted observation of the Proxima Centauri system. Initially buried in a massive dataset, the signal was almost lost in the noise. But researchers, combing through the recordings with advanced algorithms, identified its unusual traits. It fit 2 key criteria for an artificial source. It was extremely narrow in frequency, something rarely produced by natural cosmic processes, and it showed a frequency drift consistent with the relative motion between the source and Earth. These characteristics do not prove alien life, but they are compelling enough to warrant global attention. If BLC-1 or the new signals from Proxima B proved to be genuine communications from another world, the implications would be staggering. Such a finding would not just change the course of astronomy, it would alter the trajectory of human civilization itself. Even now, research teams are planning follow-up observations, hoping to capture more data and confirm whether the signal repeats or changes over time. Next-generation observatories like the Extremely Large Telescope and the Habitable Exoplanet Observatory will one day have the capability to directly image planets like Proxima B, studying their atmospheres for chemical signs of life and perhaps even detecting city lights or engineered structures. The world now stands at the threshold of a discovery that could answer one of humanity's most enduring questions: are we alone? For the first time, we may be close to a definitive answer. Until then, astronomers will keep listening, the public will keep wondering, and the universe, vast, ancient, and silent for so long, may be preparing to speak. Scientists analyzing data from Proxima B had to sift through nearly 4 million individual signals captured by the Australian radio telescope. The process was painstaking. Every signal was filtered and compared against known terrestrial sources, eliminating countless false positives. In the end, they narrowed the data down to about 5,000 distinct signals. Among them, one stood out. This particular signal could not be matched to any human-made transmission, and it bore a narrow-band technological signature that drew immediate attention. Intriguingly, the signal only appeared when the telescope was aimed directly at Proxima Centauri and was detected over a continuous 30-hour observation period. Detailed analysis traced the source back to Proxima B, an exoplanet discovered in 2016 through the radial velocity method. This method detects the subtle motion of a star caused by the gravitational pull of an orbiting planet, visible in the way the star's light shifts toward blue as it moves toward Earth and toward red as it moves away. When this pattern repeats in regular cycles over time, astronomers can confirm the presence of a planet. Proxima B itself is remarkably similar to Earth. Its radius is about 1.1 times that of our planet, and its mass is roughly 1.3 times greater, suggesting a rocky surface and a similar density. Yet there are notable differences. One of the most striking is its position in its solar system. Proxima B orbits extremely close to its parent star, just 0.05 astronomical units away, compared to Mercury's 0.39 astronomical units from our Sun. By ordinary standards, this would make the planet unbearably hot. But Proxima Centauri is a faint red dwarf, so the planet receives only about 60% of the energy Earth gets from the Sun, placing it comfortably in the habitable zone where liquid water could exist. The universe is home to countless worlds, and our discoveries so far are just the beginning. To date, astronomers have confirmed 4,935 exoplanets, with 65 more recently added to NASA's Exoplanet Archive on March 21, bringing the total to over 5,000. These planets range from small rocky worlds to gas giants larger than Jupiter, from scorching hot spheres to potentially life-friendly environments. Some of these planets stand out for their Earth-like qualities. One in particular, Kepler 1649c, shares remarkable similarities with our own world and is considered one of the most habitable exoplanets discovered so far. Of the thousands found, around 55 are categorized as Earth-like, though many remain unexplored in detail. With rapidly advancing technology, especially the capabilities of the James Webb Space Telescope, we are now closer than ever to identifying planets that could truly support life. The James Webb Space Telescope represents the most advanced astronomical instrument ever built, boasting a sensitivity roughly 100 times greater than its predecessor. One of its key missions in its first year is to search for and study distant worlds beyond our solar system, exploring how they form and whether they could harbor water or biological life. By studying the birth of stars and planets, Webb allows scientists to connect the early stages of planetary systems to their mature forms, linking their findings to the history of our own solar system. Infrared observation is Webb's greatest strength, and it is essential for several reasons. Infrared light can pass through dense clouds of cosmic dust, detect the heat signatures of young stars and planets, and reveal the presence of important chemical compounds such as water and organic molecules. Mid-infrared light can penetrate clouds 20 times denser than those visible to optical telescopes, making it invaluable for studying newborn stars hidden within their stellar nurseries. Young stars and giant planets both begin their lives as massive, swollen bodies that slowly contract over time. As stars grow hotter with age, planets cool, yet both shine more brightly in infrared wavelengths than in visible light. This makes Webb an exceptional tool for finding new planets and stars, as well as for studying the physics of their formation. Its MIRI instrument is designed to search for hot molecular gas around young stars, a potential sign that rocky, habitable planets could be forming. Much of Webb's early research is focused on understanding how planetary systems produce the molecules necessary for life. These investigations are not just about detecting distant planets but about uncovering the conditions under which life might emerge. With each new discovery, we get closer to answering one of humanity's oldest questions: whether life exists beyond our own world, and Proxima B's mysterious signal might be one of the first clues leading us there.